Hi everybody, and welcome to lesson 7 on domain and range. The definitions are written there on the page for you. The domain of a relation is all the possible values on the horizontal axis, usually the x, and the range is all the possible values on the vertical axis, usually the y. It is important that you remember which one is which. That domain is referring to the x-axis and range is referring to the y. You will just become familiar with it, but one way that you can remember in the meantime is that domain and range are in alphabetical order and x and y are in alphabetical order. So domain goes with x, range goes with y. If you're asked to supply the domain for a function and you give the range, you just won't get any answers for it. So it is very important that you learn the terminology. There's a couple of different notation methods. The one that you're probably most familiar with in this little table is the number line graph. We saw these in year 10 and we know from our previous lesson that when the dot is coloured in like it is here, that point is included in the domain or the range, whichever one it is. In this case it's x, so it's domain. When the circle is open, it's not included. The way that we write that using set notation or interval notation, which is the first two columns, is this. This little set of brackets, it reads the set of all x such that x is greater than or equal to 3. I'll write that down here. The set of all x such that x is greater than or equal to 3. And you would write it, when you're writing the domain, you would also write domain equals the set of all x such that x is greater than or equal to 3, and then close the brackets. That's the version that I personally prefer to use. I'm not going to ask you to specifically use set notation or interval notation, but the other way of expressing that is in interval notation, which is x, and remember the funny e means is an element of. So x is an element of the set of numbers from 3 to infinity. Now notice that one's got a square bracket and one's got a curved bracket. If you have a look at the little note down the bottom here, the curved bracket means the endpoint is not included, whereas the square bracket means the endpoint is included. So that tells us that in this little notation here, the 3 is included because it's got the square bracket, and that's confirmed by the presence of the solid dot. And the infinity is not included, which is why it's got the curved bracket. And another point to note on that one is that positive and negative infinity are never included and always have a curved bracket. So you're welcome to use whichever notation you like. I don't much mind. Having a look at the next examples, in this one we've got 2 is not included. It's shown by an open dot, and we're looking for values that are less than 2. So this one in set notation is the set of all x such that x is less than 2, and then close brackets. Or x is an element of the set from negative infinity to 2, and neither negative infinity nor 2 are included. So that's when we've got an open interval. Sometimes we'll have a closed interval where you specify, so this one here where we've got 2 is not included but 1 is included, and so then we have the set of all x such that x is greater than negative 2 but less than or equal to 1. Using interval notation, x is an element of the set not including negative 2 up to and including 1. So careful with the brackets. I think the reason that I like set notation rather than interval notation is that a set notation, you really read the notation as you go, whereas the interval notation doesn't read quite as nicely. If we've got two distinct regions that we need to include, we've got this one here which is less than and including 0, and this region which is greater than but not including 4, then we use again, it's a part of set notation. You might have seen it in Venn diagrams. So looking at the set notation here, the domain is the set of, oops, hang on, what's going on? The set of all x such that x is less than or equal to 0 in union with x greater than 4. So that means both of those little pieces of notation apply. So it could be x could be anywhere in this little part, which is less than or equal to 0, or it could be anywhere in this little part, x is greater than 4. That's probably the trickiest one. In the next little video, we'll do some examples.